In this video lecture, we shall discuss about testing hypothesis on the equality of variance of two populations. So let us say we have two populations with variance as sigma 1 square and sigma 2 square, and here we want to test a hypothesis, that null hypothesis, that the population variance of two populations are equal. Let us take, we are considering samples of size n1 and n2 from the corresponding first and second population with sample variance as s1 square and s2 square. So in this case, our null hypothesis will be h naught, that is sigma 1 square is equal to sigma 2 square. And the test statistic is, we denote it as f naught, that is equal to s1 square by s2 square. This f naught will follow the f distribution with degrees of freedom v1 and v2. v1 is n minus 1, that is the 1 less than the first sample size, and v2 is 1 less than the second sample size. Now, to test any hypothesis, we need a level of significance and alternate hypothesis. Here, for an level of significance alpha, we can have three different cases of alternate hypothesis. First case is the level of variance of the populations are not equal, that is sigma 1 square not equal to sigma 2 square. Second case is variance of the first population is smaller than the variance of the second population. And the third case is variance of the first population is larger than the variance of the second population. So first case we call it as a two-tailed test, second case lower or left-tailed, and the third one is upper or right-tailed test. In the two-tailed test, both the sides we will have rejection region, and lower or left tail test we will have left side portion will be a rejection region, and in upper or right tail test, right side part will be a rejection region. Now the critical region or the rejection region will be, in the two tail test, f naught, f of alpha comma alpha by f alpha by 2 of v1 comma v2, and f naught less than 1 minus alpha by 2 comma 2 of v1 comma v2. Here just I will go with the graph. If I This is a graph corresponding to f distribution, and f alpha stands for right side area is alpha. If I have right side area is alpha by 2, then it will be f alpha by 2 corresponding to the degrees of freedom v1 and v2. And the corresponding, the left side rejection region will be for f 1 minus alpha by 2. Here right side area will be 1 minus alpha by 2 corresponding to same degrees of freedom. But there is a relation, there is no separate table corresponding to f1 minus alpha by 2. There is a relation between f alpha by 2 and f1 minus alpha by 2. That is f alpha, okay, just I will take the other way. f1 minus alpha by 2 we corresponding to degrees of freedom v1 and v2 will be equal to 1 over f alpha by 2 with respect to degrees of freedom v2 and v1. Degrees of freedom will not be symmetric here. The numerator degrees of freedom and denominator degrees of freedom will interchange. Whenever I change, the corresponding f alpha value will change. So we always use this f alpha by 2 of v2 comma v1 to get f 1 minus alpha by 2 of v1 comma v2. So similarly, we can have the rejection region for lower or left tail test and right tail test, and the remaining portion will be the acceptance region in all the three cases. Okay. We'll illustrate this with an example. Let us go for an example. An experiment was performed to compare the abrasive wear of two different laminated materials. 13 pieces of material 1 and 10 pieces of material 2 were similarly tested by exposing each pieces to a machine measuring wear. In each case, the depth of wear was observed. The sample of material 1 gave a standard deviation of 4, while the sample of material 2 gave a standard deviation of 5. Can we conclude at the 10% level of significance that the variance is in abrasive wear of material 1 and material 2 are equal? So here we are testing only the equality. That means null hypothesis will be sigma 1 square is equal to sigma 2 square. We have to test whether they are equal or not. It's nothing about any of them is large. That means the alternative hypothesis will be sigma 1 square not equal to sigma 2 square. Now let us come back to the given data. It is given that material 1 is 13 pieces collected, that is N1 is 13, and material 2 10 pieces are collected, so N2 is 10, and material 1 has standard deviation as 4 and material 2 has standard deviation as 5. So in we usually use variance, so variance will be 16 for material 1 and variance is s1 is 4, s1 square is 16, s2 is 5, s2 square is 25. Now if we come to the test we need to apply, we are checking the equality of variance, so it is a f test, and in particular we are applying two-tailed f test, and alpha is given as 10%, that means it will be 0.1, and we want here f of f 1 minus alpha by 2, alpha is 0.1, so alpha by 2 is 0.05, so 1 minus alpha by 2 will be 0.95, 12 comma 9. The first degree of freedom is 13 minus 1 12. Second degree of freedom is 10 minus 1, that is 9. So f 0.95 of 12 comma 9, which is less than f naught, less than f 0.05 of 12 comma 9 is the acceptance region. So right side bound we can directly determine from the table. Left side bound we have to convert it in terms of f of 1 minus 0.95, 1 minus 0.95 we will get it as 0.05. So 0.05 corresponding to degrees of freedom 9 and 12. You can use this determined from the table. V1 is 9, V1 is 9 and V2 is 12, corresponding to alpha value is 0.05. So here corresponding F value is 2.80. So here the denominator term is 2.80 and the numerator, the right hand part size is here V1 is 12 and V2 is 9. Again I will go back to the table. Here up to 9 is there. I'll move on to next table. Here I have 12, v1 is 12 and v2 is 9. Corresponding value is 3.09, 3.07. So acceptance region will be 1 by 2.8, 1 by 2.8. This value is nothing but 0.3571, less than f naught, less than 3.07. Now if I calculate the test statistic value, we'll get s1 square by s2 square, that is 16 by 25, and that value is 0.64. We can observe that this 0.64 is between the inside the acceptance region. That means our conclusion will be here: do not reject null hypothesis. That is, there is no conclusive evidence to say that the variance of the two populations are different. Okay. Let us check one more problem on this. Here, a study is conducted to compare the lengths of time required by men and women to assemble a certain product. Past experience indicate that the distribution of times for both men and women is approximately normal, but the variance of the time for women is less than that for men. A random sample of times for 11 men and 13 women produces a standard deviation of 6.1 and 5.1 respectively. Test the hypothesis that sigma 1 square is equal to sigma 2 square against the alternative sigma 1 square greater than sigma 2 square at 5% level of significance. So let us take men and women. We have two set of data with subscript 1 corresponding to men and subscript 2 corresponds to women. Here n1 is given as 11 men and n2 13 women, and standard deviation S1 is 6.1 and standard deviation S2 is 5.1. So here both alternative and null hypothesis are stated directly. Null hypothesis is sigma 1 square is equal to sigma 2 square, and alternate hypothesis is sigma 1 square is greater than sigma 2 square. So it is a right-tailed F test we have to apply, and also level of significance alpha is given as 0.05 and acceptance region will be f naught less than f 0.05 of 10 comma 12. We need to determine f 0.05 10 comma 12. v1 is 10, v1 is 10, v2 is 12. That value will get it as 2.75. So this value is 2.75. Now the required test statistic is f naught, that is s1 square by s2 square. We'll get it as 1.4306. We can observe here f naught value is less than 2.75. That is, f naught value is inside the acceptance region. So we can give a conclusion here: do not reject null hypothesis.